All right, Math 1, we are going to finish up this chapter with graphing radical graphs and what is called piecewise functions. So if you take a look down here, this is your square root graph. It looks like this. Your x's cannot be negatives. The best you can do is start at 0 and you work your way up, and hopefully you're going to put in your perfect squares. These are, 0 times 0, 1 times 1. You got your 2, you put your 4 in. If you're dealing with square roots, I'm not sure why they put that one in, but you can put any number you want really in. But what your graph will always look like will be something like that. It won't cross down here into the negatives on your x because you cannot put negatives into square roots. You can on cube roots, but not onto square roots. So all you're going to do is make yourself a chart and start solving this. All right, so we're going to go to the top of page 355, and we're looking at this function right here, and we can deal with our x's and y's. So let's start with 0. So if we put 0 in here, we get 0 plus 4, which is 4. The square root of 4, got to follow your order of operations. So the square root of 4 is 2, and 2 minus 2 gives us 0. So we're going to start at 0, 0. Now, in this case, you can put whatever you want in, but I like to deal with perfect squares. So the next perfect square that I can put in, actually you can put some negatives in this one. The reason I say that is because as long as you can keep what's under the radical sign positive, you can go ahead and put negatives in. Since we're adding a 4 to it, we can put a few negatives in here. So let's try -3, and you'll see why I'm going to use that in a minute. So I'm going to put in a -3. So if I do -3 plus 4, I get the number 1. 1 is a perfect number. So what is the square root of 1? It's 1. And 1 minus 2 is -1. All right, the next thing I'm going to put in is a 5. This will be my last point. Hopefully it'll give us an idea. If I put a 5 in here, 5 plus 4 is 9. The square root of 9 is 3. And then 3 minus 2 gives me a 1. All right, so actually I'm going to put in negative. I think -4 is the best we're going to do. Whoops. I will go ahead and put in a -4. I think that will work. If I put a -4 in here, you get -4 plus 4, which is 0, and 0 minus 2 is -2. That's as far as I can go on the negative side. So that will give me a nice starting point. It's what would make underneath a 0. All right, so -4, -2. So we're going to go 1, 2, 3, 4, 1, 2. This is the best we can get. We cannot go any further on the negatives because if I do, I'll get a negative on the radical. Let's see, -3, -1, 0, 0, and then 5, 1. So 1, 2, 3, 4, 5, 1. All right, so we're going to start here, and it's the same shape as the graph on the other one. So, oops, that was a horrible hitting, but it just kind of comes up and it curves and makes that little curve like that. Now, this will be the absolute last point over here, so it's going to go this way. All right, so let's try another one. Again, let's start, I'm going to organize my thoughts a little better here. Let's start with making it a 0 underneath. So to make it a 0 underneath, 1 is the best we're going to do. So 1 minus 1 is 0. 0 minus 3 is -3. So I cannot choose any x's less than 1. So if I choose a 0 for my x, I'm going to get a negative underneath, which cannot happen. All right, let's see. I'm going to try 5. No, let's do 2. Let's do 2. 2 minus 1 is 1. The square root of 1 is 1. 1 minus 3 is -2. Now let's try 5. So 5 minus 1 is 4. The square root of 4 is 2. 2 minus 3 is -1. So 5 gave us -1. We can do 10. 10's, I guess, as far as I'm going to go. So 10, if I put a 10 in, and the reason I'm trying to do that is to get perfect numbers under here. So like the 0, the 1, the 4s, the 9s. So if I put a 10 in here, I get 10 minus 1, which is 9. The square root of 9 is 3, and 3 minus 3 is 0. All right, so that's probably as high as my graph is going to go. So it looks like I got all positives, and I'm working my way up that one. All right, so I'm going to make my graph. This is going to be my y-axis. All right, and my x. All right, so 1, -3 is my absolute endpoint. 2, -2. 5. So 1, 2, 3, 4, 5, -1. There's my curve. And then I'm hoping this goes 10, 0 right here. So this is where it's going to kind of start, and we curve out this way. Okay, so on this one, we'll start with a -5 will be the best we can do on the x's. -5 will get us a 0 underneath, and 0 plus 1 is 1. Let's see, I could do a -4. -4 plus 5 is 1, and 1 plus 1 is 2. Let's see, to get a 4 underneath, we could do a -1, and -1 plus 5 is 4. The square root of 4 is 2, and 2 plus 1 is 3. To get a 9 underneath, let's see, because we did 4, so 9 would be the next one. We're going to use the number 4. 4 plus 5 is 9. The square root of 9 is 3, and 3 plus 1 is 4. 16 would be our next perfect number to put in here, which means I need to put in, looks like 11. I don't think my graph's going to go up to 11. All right, so I'm going to skew this just a little, and my y's are all positive. All right, so -5, 1, so 1, 2, 3, 4, 5, 1 will be right here. There's my absolute left point. -4, 2 is here. -1, 3 is here. And 1, 2, 3, 4, 1, 2, 3, 4 is here. All right, so again, you start seeing that little curve point going through, and there's your absolute left endpoint. All right, so all the graphs will kind of look like that when you are doing radical graphs. All right, if you turn over, we have a cube root function. Well, the cube root function can involve negatives, so it doesn't matter, and it's always going to be like this with just a movement, and you can do the same thing with these. The list of perfect cubes are right here. You can do -8, -1, 0, 1, and 8 are all your perfect cubes. All right, so if you're dealing with that, those are always good numbers to start with. So -8, -1, 0, 1, and 8. The cube root of -8 is -2, because -2 times -2 times -2 is -8. So the cube root of -8 is -2, and -2 plus 2 is 0. The cube root of -1 is -1, and -1 plus 2 is 1. If I put 0 in there, you get 2. Put 1 in here, the cube root of 1 is 1. 1 plus 2 is 3. Stick 8 in there again. The cube root of 8 is +2, and 2 plus 2 is 4. All right, I'm not going to be able to do the -8, but I'll do the -1. So looks like all my y's are positive. So I'm going to go like this with my graph. I'm not doing -8, 0. You know, that would be way down here. All right, so -1, 1, 0, 2, 1, 3, and then 8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. It would be here. So it's going to go like this with the graph. Okay, it's kind of the shape of every one of them will look something like that. All right, this one, again, I would put in like -1, 0, 1, and 8 and see what it does and just kind of know the feel for the thing. Okay, piecewise functions. Let's spend a little time with this. These are confusing. What you're doing is kind of putting pieces of graphs on there. So these are all your linear. If you remember, y equals mx plus b. You start at your b, your m is your slope. So that's kind of what this is. So this first one, you're doing y equals, this is your y equals x minus 3. But I'm only doing it for values greater than or equal to 2. All right, so I only want x values when it's y is greater than or equal. So what I would normally do is start at -3. All right, and then I'd rise 1, run 1, rise 1, run 1. Well, right here, I'm at 2 for my x. So that's where I'm going to start. All right, I want to start when x is greater than or equal to 2. So I imagine myself graphing this. So I am graphing at starting at -3. My slope is 1 over 1. So at -3, I go up 1, right 1, up 1, right 1. I've just hit my x of 2, and now I can keep going up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So what this is going to look like, it's a linear line that starts right here and goes like that. Okay, so I'm starting at 2 on my x-axis. This one is y equals 3x minus 2, but I want all values where it's less than 2. All right, so I would normally start at -2 on my y-axis, and then I'd rise 3, run 1. So start at -2, 1, 2, 3, 1. All right, then 1, 2, 3, 1. Well, here I'm above my 2, so I'm going to circle it because it's not equal to it. And then I'm going to work myself back where we started because these are all the values that were less than 2. So at my -2, and then 1, 2, 3, 1 was here. So I'm going to start here. I'm going to go like that. And these are all my x's that are less than 2 are this way. And that one's all the x's greater than 2. So that's your piecewise function. A little bit confusing, but that's what it looks like. So down here, I only want the values for x greater than 0, greater than or equal to 0, and here I only want the values of less than 0. So we will start each of them. So y equals 1/2 x plus 1. All right, so... All right, so this one's telling me I'm going to start at 1, where this is my x is 0, so that's good. So I'm going to start at 1. So I can go ahead and plot that because I want when x is 0, and that is a 0 on the x-axis. Then I'm going to go up 1, right 2, up 1, right 2. So it's just going to be a line that starts right there and goes like that. This one, I'm going to start at -4. So 1, 2, 3, 4, but that's my 0 on my graph. So 1, 2, 3, 4. I need an open circle because it's not equal to 0. And then it's like up 1, right 1. Well, I can't go this way because now I'm going into my x is greater. I need to be only going down this way with it. I should have extended my graph. So it's going to be down 1, left 1, down 1, left 1, like that. And that's what that graph is going to head just this direction because I want all values when x is less than 0, which are all these values when x is less than 0. All right, let me know if you have any questions. We have a quiz on Thursday. I will not put a lot of the graphs. I'm going to focus more on functions and square roots. That's important. I will put probably one of the square roots and one of the piecewise, just similar to what we've done here. Just let me know if you have any questions.